Hey, QED Coders, this is Michael. This is going to be another solo episode. Jan is on his way back from his holiday vacation. But today I've got something really exciting to share with y'all. So I have been working on real-time updates in a Jinaga application. And I've got some progress that I really want to share with you. So let me show you the example application that I built. Let me show you how we can enable real-time updates to the client, and then we'll go behind the scenes and see how Jinaga implements that. And then maybe we can spend some time looking at some alternatives to how Jinaga does that right now, and we can talk about how it might do things differently in the future. So let's take a quick look at here we go. Yeah, this is Chat App. So you will find Chat App on GitHub. In fact, let me go ahead and show you where it is on GitHub. So we'll go to github.com/jinaga/chat-app. So here's the Chat App. It tells you how to get it set up and running. And it tells you a little bit about the model. So we're going to walk through this. But go ahead and download this code and give it a shot yourself. So here we are, Chat App. This is a really simple model. I mean, so simple that it's a little bit. Oh, this is Jinaga. Let me open up Chat App. Where is? You know what? I'm going to do it this way. I'm going to come in here, and I'm going to say I want to use code to start Chat App. Thought that's where I cloned it. Hold on a second, and let me make sure that I've got that loaded in the right place. Here we go. Okay, here is the Jinaga Chat App example. And it uses a very simple model. Let's go ahead and run through the setup steps real quick. So, setup is really easy. npm CI. Install all the dependencies. And then we do npm run dev to start the development server. This one's using Vite. So I'm going to be switching all my examples over to Vite for the React stuff. Yeah, it's the Create React App server is finally deprecated, and they said move everything over to Vite. So that's what I will do. So we've got a very simple chat app going on here, so I can select a topic. Let's talk about Jinaga. So select that topic, and as you can see right now, it is having some difficulties. That's because there's one more part of the setup that I forgot to do. We're trying to save to the Jinaga replicator, and it says get your own replicator. Yes. That's because right here in the .env, the Jinaga replicator is set up like this. So let's also set .env.local, and that overrides .env. And here we can set our own Jinaga replicator URL. How do you get a Jinaga replicator URL, you might ask? Well, you can get one for your very own. Go to dev.jinaga.com. Log in using GitHub and complete your two-factor authentication. Two-factor authentication. Great security, bad for compelling content. 228.986. There we go. Your device supports passkey. Yeah, let's do that later. All right. So you sign in. You will start with a blank screen here. You can just create a new replicator. I have created one ahead of time, and that is called Chat App. And so once you create the replicator, you will have a URL. You will also have the publish button. Don't forget to hit the publish button. That's very important. So go ahead and publish your application. That way this URL will be live. And then you can paste it in here, and that is your backend. Okay, so it's restarted the server. And if we go back to Jinaga chat, let me clear that. Now when I go to Jinaga, then it says, okay, I can connect to the replicator as a service. I can pull feeds from that replicator, and the feeds that it gets back this one feed here. So let me start reading from that feed. Here we go. We're reading from that feed, and we get back a fact. This fact is this particular chat right here. So how do I know it? I'm going to call load, and I'm going to say, hey, I am interested in this particular fact right here that I just got the hash from this feed. So what is that fact all about? And it says, well, this is a tree. We've got a chat topic and a chat message in this little graph. The message refers back to the topic as a predecessor. And so the message says, I have a simple chat app working, and the topic has the name Jinaga. So I just said, I'm interested in Jinaga. And so it pulled that back, and then I could run this little query and see all of the chats inside of that topic. Okay, have a little chat app working. Now, there's something really interesting happening here. So we've got the feeds, and then we pull from this one feed right here. And you can see that bar right there. And then when it gets back its result, then it does the load. So that bar right there, we're going to refer back to that bar, because the important thing here is that it has an endpoint. It stops. It says, nope, nothing else happening. And that means no real-time updates. So we're going to fix that. First, let's take a look at the chat application and see how everything is put together. So up here in the model, I've got chat.typescript. So here's the topic. The type is chat.topic, and it's got a name. So we already saw that inside of the payload here. When I looked at these, I see there's the name field. And then we've got a chat message. The type is chat message, and it's got a topic and a field called text. So the topic is another object, so that is a predecessor. And text is a value, so that's a field. So we can see here, here's chat.message. The predecessor is topic. There's the reference to it. And the value is the text field. Okay, so that's the very simple model that we have going on here. So whenever I enter a topic, then what happens? I have this topic view model right here. So use topic gives me back that topic view model. This is my way for entering a topic using the keyboard. And then I hit the select button. And then what it's going to do is create a brand new topic with that topic name, calling j.fact. So that creates the topic, that sends it up to the replicator, and that holds on to that reference. So now I've set that topic, and I have that available to anybody who is interested in what is this topic. Now that I've got that, the message list comes live, and the message list has this view model. So the use message list takes a topic view model that gives me access to the topic. Once I've got that topic, then I can start an observer. I can watch for messages in that topic. When I receive them, I'm going to add it to this collection right here, this set of messages. And then when I'm all done with that topic and I switch to another one, or I just shut down, then I'm going to stop the observer and I'm going to clear out the messages. So that's my messages view model. So that right there is what sets up the observer, that sets up the watch. Now, watch is one of the ways that you can receive information from Jinaga. So another one is query, right here. So query, is it going to give me some help? No, it's not going to give me help. Anyway, query will get you the results and then stop right there. So query is just a one-time fetch the results. Watch creates an observer, so it's going to continue receiving results. But that observer is only local. So that means if somebody were to send a message right from this device, then it would appear. Let me show you that. So let's go back to the app, and then I'm sending a message. So I send the message. It calls save. So it's sending the message to the replicator, but we've already stopped listening. So we're not going to receive any messages from somebody else. But nevertheless, because I've got a watch, it added that message to the list here. So it updated that list. So watch is looking for anything that happens locally. Let me go ahead and set up a side-by-side so you can see everything that's happening here. So I'm going to duplicate this tab, take that off, and pop that over here. Okay, we got our side-by-side view going. So from this side, I'm going to also open up the DevTools, and let's take a look at the Jinaga topic. And so you can see it does all of the same calls where it saves the topic. The replicator says, I already know about it, but that's fine, cool. It's the topic. Then it gets the feeds, then it fetches from this one feed, and this time when it fetches from this one feed, it gets back two references. There are two messages in this feed. All right, so I've got these two hashes. Let me go ahead and load those two hashes. So, there we go. Here's the payload. So load those two hashes, and then we get back the response that is these three facts in a graph. So let's look at this a little bit more closely. I've got a topic that is Jinaga, and then this hash you can see is the predecessor both for this message and for this message. So both of those are coming back. And so that way it's able to see, I have a simple chat app working, I'm sending a message. Fantastic. So Now, if I were to come over here and send a message, is anyone listening? Send it. So it sends it to the replicator, and because of the j.watch, it updates the user interface. But this other one didn't hear about it. That's because it stopped listening. If we were to refresh, go back to Jinaga, then it loads. We can get the results back. They're out of order. That's an important thing that we'll talk about in just a second. But the important thing right now is we don't have any real-time update. How do we enable real-time updates in Jinaga? Please tell me. The suspense is killing me. Well, that's where the third way of pulling results from Jinaga comes in. So there's query, give me the results right now and stop listening. Watch, set up an observer, but only respond to things that are happening locally. Subscribe sets up an observer and continues listening to the remote replicator. That's it. Change watch to subscribe, and you've got it. So, save that. It does the builds. That's just a quick client-side update. And so now, I don't know if it did a hot reload on this, but we can find out. Let's see what just happened here in the network tab. So we did an app refresh. We've got a brand new version of the message list view model, and then here we did another connection to the feed, sending in that bookmark. I didn't talk about the bookmark, but that's an important thing. And the request headers said I accept application X Jinaga feed stream. That is the key that tells the replicator, okay, we're going to be keeping this connection open, and I want you to keep sending responses down this pathway. So, yeah, I forgot my picture disappears when I maximize something here, so I'll try not to do that. So yeah, it hot reloaded, and now we've got the application working. So I can hear you. Send that, and boom, the other side hears about it. So now we've got this real-time communication between these two clients of the replicator. So how did that work? So here I did a save. And over here, you can see that at the same time, this feed right here continued, and then it received some information, and then it did a load in order to pull that information in. Well, let's see if we can see the information. We cannot. And I believe this is because I don't send content length with this response, because I don't know how long it's actually going to be. It's just when I have new information to send, I put that onto the stream, and so I don't think the browser tools are set up to do that. So that is, but you can see from the bar here that it kept the connection open, and then it called load. So if I say, can you hear me? And I send that, boom, we hear that. The connection remained open, and you can see here's the first load. There's another load that happens right here. So we've got this real-time communication, and all we had to do is change watch to subscribe, and we've told Jinaga that my application is interested in real-time updates. So I'm curious, how long have we been yapping? So we've been talking for about 2.7 minutes. There's going to be something interesting that happens at the 4-minute mark. Let's go ahead and keep talking back and forth. Yeah. Yes, I can. Boom. We can see that the same thing is happening on the other side. It's symmetrical. No reason not to expect that. And now we've been talking for 3.5 minutes. We're almost there to the 4-minute mark. Something to point out while we are talking about this, you can see that even when I sent the message, I got a message and I did a load. And the same thing over here. These are the two messages that I sent from this side, and I still received the message and performed a load. But now you also saw on this side, but not yet on this side. Oh yeah, it did happen on this side too. We created a brand new feed. So here we go. Here's a new feed. And now I'm pulling from the bookmark 180. Right here, the bookmark was 176. So every time I receive new information, I'm updating my bookmark locally. And that way, when I create a new connection and try to fetch new data, I try to get data from that bookmark forward. So why did it create a brand new connection after 4 minutes? Well, that's because of keep alives and retries and heartbeats and all of those fun things to try to keep this connection healthy. The server is a very limited resource, and it only has so many sockets that it can allocate to clients, and so it wants to manage those clients carefully. And so the server is going to time out after 5 minutes and close the connection. When I tested this with the browser without any kind of retry at all, I found that the browser was timing out after about 4.5 minutes. So I said, okay, let's let the browser, let's let the application time out at 4 minutes, save the browser from that headache, save the server. So now the server's 5 minutes is just kind of a fallback, just in case everything goes wrong. But after 4 minutes, it reestablishes the connection and keeps it fresh. So we've got this real-time update between these two applications. There is some really cool mathematics that's happening under the covers to make this work. So in order to get to show you that, what I want to do is on the other screen here, I'm changing to Jinaga server, making sure I've got the latest here. Okay, and then I'm going to do a code dot. Here we go. We have Jinaga server, so the other half of this communication. Now we talked about Jinaga server and real-time updates in a previous video, so you can go back to see all the details there. But we didn't get into the mathematics of how this is all working. So that's what I want to talk about right now. So under source HTTP, we have a router. So we're using Express on the server side, and so I've got this helper method here, get or stream, and it's looking for application xJinaga feed stream. And if that's in the accept header, it's going to go down the stream side. Otherwise, it's going to go down the get side. So as it goes down the stream side, it sets a bunch of headers, sends those off, and then sets that 5-minute timeout that I was just talking about, where it's going to close it and just hope that the client creates a new one. If the client doesn't create a new one, hey, that's fine. But this is the server protecting itself. So then what's on the other side of this thing? This particular stream method. Let's take a look at where this is called right here. And we pass in stream feed. Okay, so get the bookmark. And then we get some the initial response, and we send that initial response back. And then we compute the inverse, of this particular feed and then wait for something to trigger that inverse. That's the math that makes all this work. So there are two calculations that I'm doing on a specification. One breaks it into feeds in the first place. The example that we see right here, let's stretch that out and we can see this is one such feed, this hash right here. Then the that's the URL. This hash right here that happens after feeds. That particular hash 0-w blah blah blah. So that hash right there that we can see here, that was one of the responses from feeds. So given this specification right here, I want you to compute the feeds. And then it says, okay, here's their feeds. 0-w blah 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 is a feed. What that means is that it followed all the different paths that it could have taken through this specification to an endpoint. The specification is a tree. Starting at the topic at P1, then we follow down to U1 by following the successors. We're looking for the successor topics, the successor messages that refer to this topic. And so that's a simple path through this simple specification, and that's the only path through the specification. Some specifications have existential conditions, so if this doesn't exist, then return that. Well, the not exists is a different path, because if it did exist, we wouldn't have gone down this path. So you're going either down this path or this path. Some of them have projections where we are getting mutable properties of a fact, and that's a different path. And so that results in a different feed. This one's nice and simple. It gives us back just one feed. So that's the first thing. And that feed is actually just this same specification, this same path. Then the second calculation that I do is to compute inverses. Let me take you back to Jinaga.JS and let's take a look at oops. That's what happened. I want to go to Jinaga.JS, not the root Jinaga folder. Okay. Now we're in Jinaga.JS. And I've got some tests that help to describe what's happening here. So we have the feed calculation. So given the feed, when I get the feeds of a simple specification, like the one we were just looking at, I get back that one feed. That one specification is the only feed. If I go a little bit more complex and I've got an existential condition, now I get back two feeds. One of them goes down the condition. So you can see this revoked, that comes from the condition. The other one goes down the regular path and includes the existential condition. So I don't want anything that's been revoked when I go down that path. So this is telling me if somebody revokes an assignment, tell me on this channel. If I have a brand new assignment, tell me on this channel. But when somebody revokes an assignment, remove it from this channel. I don't want to hear about it anymore. Then with the deeply nested projections, we've got children, we've got grandchildren. These are other paths through the specification. They each result in their own feeds. So I get one feed that is just this part, and then I get one feed that gets me the children, and then I get one feed that gets me the grandchildren. So 3 separate channels. Tell me about parents, tell me about children, tell me about grandchildren. So number 1, separate your specification into feeds. Number 2, invert your specification. when you invert a specification, you flip it around, you go backwards. So I've got a specification that takes me from Office to, this time I used the parser here to just write the specification in code. So given a company, I find all the offices. So I go down to the offices. The inverse, given an office, find its company. I go up to the company. It's just a predecessor. I look it up, and I return that. So this result is you won the office that I asked for. And that's because that was the result of this original specification. So I said, okay, I found the company, but here's the office that you asked about. Seems kind of weird, but as we get into more of these, we'll see why. So let's talk about negative existential conditions. All right, given this company, let's find offices in that company where there does not exist office closed. Okay, so now when I invert, I'm going to find two inverses. Is that true? Yeah. Yes, that is true. I find two inverses. So one of them is starting from the office, giving the company, as we saw before. And then the other one goes all the way into that negative existential condition. So given office closed, find the office and the company. So it takes the path up from that direction. What is so special about an inverse? If I learn about office closed, then I need to know who to notify. So I run the inverse, and I run the inverse of this specification, and I will find, okay, if somebody is watching, if somebody is observing this specification, starting from the company that I compute right here, then they're interested. And furthermore, the result that they're interested in is U1. So I just learned that an office was closed. They are looking at the offices, so I tell them, okay, that's the office that you should remove from your results. So that's what inverses will do for you. Inverses will invalidate caches. They will update user interfaces, and they will help it so that we can notify peers. So what's really happening here? When I compute the feeds for this specification, I get back just one feed, which is that one path, and then I invert it. So the inverse tells me that when you hear about a message, and then you need to notify people who are looking at this particular topic. So if somebody is watching the feed that starts from that particular topic, then push the this new feed to them. That's the magic. So what that means is if I'm on this page here, that page there, right now we're both looking at the Jinaga topic, still there. Blink. Yes, still there. And that's because it's keeping that connection alive. You see that 4 minutes has elapsed, 4 minutes, 4 minutes. Keep renewing that connection. And so now one of them goes away. One of them is interested in a different topic. So here I'm looking at, I don't know, we're going to talk about SignalR. So, boom, let's look at SignalR. So we've got distraction for .NET. And other client languages. Yep, there actually is SignalR for JavaScript as well. But, boom. All right, so we are talking to people about SignalR over here. And over here, I'm still talking about Jinaga. Notice right here, the feed, let's go to the headers. The feed is different. Well, you can see it right here, ZCG, as opposed to 0-W. We computed a different feed because this specification is starting at a different point, starting at a different topic. So that means that over here, hello, when I tell the replicator, hey, here's a new message, it computes the inverse, and it finds, oh, anybody subscribed to the Jinaga feed needs to know about this. People subscribed to the SignalR feed don't need to know about it. I didn't get pinged on this side. So I'm getting a subset just according to the specifications that I provide to subscribe and the starting points of those specifications. So that takes that specification starting point, breaks it down into feeds, and then computes the inverse of each of those feeds so that when I receive a fact that matches that inverse, it knows which feed to notify, which notifies the client. So all of that's happening just with math. It's just figuring it out, doing the right thing. What's really exciting to me about this is that means the developer doesn't need to make any decisions about who to notify and when. The developer doesn't need to figure out when to update caches. The developer doesn't have to figure out when to update different parts of the user interface. They just set up observers. They watch, they subscribe, and things happen. So I, of course, researched several different methods for making all of this work. And so I learned a lot from that research. We just mentioned SignalR, so let me talk about, here's Socket.io, here's SignalR, yeah. So SignalR, part of ASP.NET, so it works beautifully in .NET, so you can use a .NET client, you can use a JavaScript client. I think they've got other client libraries as well. But the server side is in your ASP.NET application. You write that using .NET. So when you create an ASP.NET server, you can create a hub. So this tells you all about what hubs do. There's another page that goes into the specifics of how the hub works. And once you've got a hub, then you can connect your different clients to that hub, and then you can call these methods in order to figure out which sets of clients are available to you. So you receive a message from a client. Now, within that context, you can tell who is the caller. I can send a message straight back to that person. I can say others. Send a message to everybody except for that person. Or all send a message to everybody. I can also group clients together. So I can define a group and then put a tag on each of the different clients, some kind of label that puts them in this group or that group. And then I can get that list of groups. I can notify everybody in a particular group. I can notify all groups except for this one particular group. I can notify everybody in this group except for this one person. So I get to choose how I subdivide the users. But here's the problem. As the application developer, I have to choose how I subdivide the users. So I'm thinking about how I notify inside of this this server-side code. So compare that with, boom, this. Here, as a client, I subscribe to a specification. Here, give me the messages in this topic, and that's it. So that subscription, that specification, and that starting point give the server enough information to just compute who's interested in what. So as the application developer, I don't have to think about it. So that's what I really love about this. Furthermore, what is that server? That server is a replicator. It's not running my application code. I just went to dev.jinaga.com and I created one. There's no application code running up here. This is just a generic replicator. So I'm not even deploying application code. I don't have to write code to set up hubs in the first place. It's just there. So that's pretty exciting to me. I think that's kind of awesome. Now, yes, I did want to talk a little bit about what it's doing under the covers. For that, we went into a little bit more detail in that last video, as I mentioned. But to kind of recap here, we're using server-sent events, kinda. So server-sent events have a client that is built into the browser. You can just use that client in order to receive messages. So they're pretty ubiquitous, pretty well supported by various browsers, but there are a couple of problems. So when you, let's see, do you have, yeah, here's the event stream format. When you send events from the server, you use a particular format that is just text with carriage returns separating these different fields. So you could say, here's the event, here's the data to go along with that event, here's an ID. And then when you're finished with that block, you use 2 carriage returns. So boom, 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 you've got these different blocks that are coming back. So, okay, I can kind of shoehorn the feed format into this this event stream format. But the other problem, which I don't think they talk about here, yeah, see, really good compatibility. The other problem is that you can't send headers with this request. So instead, you just turn on a flag and it sends the cookies. But I'm not using cookies in my Jinaga client-side applications because the server is not the thing that you authenticate with. The server is just giving you back the JavaScript code, the HTML, the CSS, but then the thing you connect to is the replicator. So the server can't set a cookie that authenticates with the replicator unless I set up some kind of a handshake between the two, which I'm not going to do. Instead, you authenticate using OAuth and you use a bearer token. So can't use bearer tokens with this unless you do something weird like put the bearer token in the header or in the, no, yeah, even that wouldn't work. So instead, I use the same kind of mechanism. I use the way that this handles sockets, but I do that all myself. So I'm not using this event stream format. I'm not using this this MIME type. You already saw that I'm using the Jinaga stream MIME type, and so now I can accept headers and I can authenticate, and this is working pretty well. There's another mechanism for connecting back to the client, and that's WebSockets. If you were to take a look through the SignalR documentation, for example, you will find that it's talking about it's going to use WebSockets. If those aren't supported, it's going to fall back to server-sent events. If that's not supported, it's going to do long polling. If that's not supported, it's going to poll. So that's a good fallback tree. I do want to support all of those different transports. Oh, right here, transports. Boom, WebSockets, server-sent events, long polling. Yeah, okay, so they don't do just polling anymore. What is long polling? Long polling is I call the server, and instead of it immediately responding, it waits a bit, and then finally it responds. So that way, while it's waiting, if it learns something new that I need to know about, it can respond at that moment. And then I make the next connection. And it waits, hears about something, responds. So long polling is just like polling, except we don't return immediately. We wait for new information. Service-sent events are actually very similar to long polling in that I make the call, but the difference is once I send back a response, I keep the connection open so I can send back another response. And as we saw, I keep that connection open from the server's perspective for 5 minutes, from the client's perspective for 4 minutes, and then I make a new one. But WebSockets are going to be an even better protocol. Let's go back to what we were just talking about here with the feeds. So you can see here, I keep on opening this connection to this one feed. That's because I'm running a very simple specification, and it only has one path through the specification, therefore one feed. What if I gave it a specification that it had an existential condition so I could delete messages? It had another existential condition so that I could restore them. You could edit the message so there was a mutable property in the projection. And then it also gave you the name of the sender, which would be another mutable property. And so you've got, like 5, 6 feeds coming back. Then this method would open up 5 or 6 sockets and keep them all open. And that starts to become a problem. So I want this to be the fallback. I wanted to implement the fallback first so that I knew that it was working, but then next I want to implement WebSockets. The reason that I have to open up each one as a separate feed, each one as a separate socket, is because the client only has one chance to send information down this feed here. So we've got the request headers that have gone out here, and this URL that says I'm interested in this feed. I can't on this same socket say, oh yeah, I need this feed too. Oh yeah, and I need this one. So because I used the same URL as the non-subscribe, the non-streaming feed endpoint, it's just one feed. So I could probably come up with a different endpoint that says I want all these feeds, but then if I subscribe to something else, then that's still a separate socket. I would really like to have a WebSocket that's from this client. There's just one WebSocket connection to the server. Says, okay, now I'm interested in this feed, now this one, and all that information flows up to the server, and the responses flow back in real time. So that is what the WebSockets transport will allow. Once I implement WebSockets, what you're going to have to do in your code? Update the library. Subscribe will still be the abstraction around that. And that's what's so cool about things like SignalR. It's an abstraction. So if something changes under the covers, the abstraction still works. The difference is the SignalR abstraction is all about calling methods and identifying who to call the methods on. The Jinaga abstraction is all about CRDTs. So they're a different abstraction at the top, but the fact that they're an abstraction means that we can change things under the covers, which is really cool. There is another one out there called Socket.io, and where SignalR is for ASP.NET servers, Socket.io is for Node servers. So you write through server side in Node. And you can see it's doing the similar kind of fallback here. Web transport, I need to look into web transport to see what that's all about. Modern update to WebSockets. Using HTTP 3. Might need to look at that, see if that's going to be a... There we go, see? Things have changed in the world. And if I had WebSockets already working, then I could implement web transport and say, okay, we're going to try that one first, and then fall back to WebSockets, and you still wouldn't have to change your code. So, cool. I learned something today. So Socket.io is another option that I've been looking at, but again, it's an abstraction that very similar to SignalR, takes the abstraction of calling methods on a client, and so you have to identify which client and you have to call the method. The advantage here being that it's JavaScript, so it's already dynamic, and so you can just name the method, and if there's a method with that name, it gets called. So it's pretty cool. But still, different abstraction, and so I'm not using Socket.io. But I am looking at how it's implemented. And then there's Firebase. Firebase Cloud Messaging is a service provided by Firebase that does what we just saw here, except with the Firebase abstraction. And so I went looking around in here to figure out how does FCM work. And it's got its own server protocol, and it's all nice and fancy abstraction, but under the covers, it's still the same kind of thing. There is no magic. We're all using the same underlying technologies in order to accomplish these things. It's just different abstractions. So, give Chat App a try. Create your own replicator. See this thing pinging back and forth. And I'm really excited to see what you might build using this real-time update technology. It's pretty exciting stuff, I think. In the meantime, I'm going to be working on the WebSockets implementation. So after an update, you'll have an even better real-time communication between clients. Then next week also, Jan will be back, and we will continue working on his Maui application. Hopefully we'll be able to get something in his client's hands very soon. So I hope that you've enjoyed this, and I will see you again next week. Take care.